So in today's video, we're going to be graphing semi-factored equations of a polynomial functions where the function is not fully factored or semi-factored. So far in this course, we graphed fully factored forms of polynomials such as the following. So where you have brackets, the factors, and where the leading coefficients of each bracket are always positive in a specific order where the x comes first. So now what we're going to do is deal with functions that don't look like this format, but look similar, but not in exactly the same. So in the above example, there are 4 brackets, and if you notice, some of them are not in order, such as this one here, and some of them have negative coefficients in that specific bracket. So what we're going to do is we're going to, I call it clean it up. We're going to reorder each term to its ideal formats, right? So, but if you notice this one here, the x is a negative, has a negative coefficient. So what we're going to do is we're going to take the negative one and factor from this particular factor. So when we factor the negative one out, it's actually negative 1, and then you bring down the negative 2, and what we have left is x minus 1, x plus 3. Now this, when you factor the negative 1 out, we end up getting x minus 4. Don't forget that everything inside this bracket gets divided by negative 1. This bracket stays the same. And because we took out the negative 1, or factor the negative 1, now we can multiply the coefficients outside, which is 2. And we end up having this. And now we can simplify this because if you notice, these two are the same. So you have x minus 1 to the power of 2, x plus 3, and x minus 4. So now we know that this function is the degree is 4. This provides 2, 1, 1. And we know that the zeros are going to be the following. We have 1, negative 3, and positive 4. So these are my x and my zeros. And I know that there is going to be a multiplicity at the 1. So it's going to turn somewhere in this area over here. It's going to either swoop up or swoop down, and it depends on the end behavior. So let's have a look at the leading coefficient. The leading coefficient right now, based in this format, is 2. So we know that it's positive 2. It's a degree of 4. We know that the end behaviors are either going up or going down. And in this case, because it's positive 2, we're going to be going up. The graph is going to go up, so it's going up, up. And then let's start from left to right. We start from here, we go down, and over here, because it has no multiplicity, it's a 1, so it has like a linear-like feature, so it just goes straight through-ish, and then we go back up. We meet up with the 1, but if you notice, the 1 has a multiplicity of 2 as a turning point, and then we go down, and then we go back up. We go straight up. There is no cubic-like feature because the multiplicity or the degree is 1. So in this example, you see that there's 2 factors, and if you notice the first factor over here, it's a quadratic. We can factor this using decomposition or however factoring you are comfortable with. So we're just going to factor this. 2 numbers that multiply to negative 3, but they add up to 2, the following. Now this one is a bit of a funny one because if you notice, the order is not preferred, so I'm going to switch it, negative 4 square. And what we're going to do right now is I would like the leading coefficient in this particular bracket to be taken out or factored out. So we're going to remove the negative 1 out, all right? But however, it's just not a single negative 1 because we have 2 of these brackets. So we're going to put another negative 1 out because we are removing negative 1s, factoring out negative 1 twice. Okay? And what do we have left? So we know that if we remove the negative 1 from each bracket, we're going to get positive 3 and a positive 4 square. Now we're going to simplify this part here. Negative 1 times negative 1 is just positive 1. So x plus 3, x minus 1, 3x plus 4 square. So I can see that all the factors are unique. And then we know that the zeros are going to be, so I'm just going to draw out the zeros. I'll use red color. So here we have negative 3. It's over here. Here we have a positive 1. And it's going to be linear, so it's just going to go straight through. Now here, just be careful that it is a negative 4, but keep in mind you have to divide it by 3. Just to show you the steps, if you want to solve for zeros of each factor, you just have to solve for this linear, bring the 4 over, negative 4 divided by 3, and we get negative 4 over 3, so it's somewhere over here is negative 4 over 3. And based on this format here, I know that the leading coefficient, the sign of it, is going to be positive. So I know that this is a degree of 1, degree of 1, degree of 2. It's going to be a quartic, like that last example. I know the end behaviors are going to be going up. I know that starting from left to right, I go down, I go up, but then I have to turn because there's a multiplicity of 2, and then I just go straight up. So in this last example, again, we have a quadratic factored here, but I know that I cannot factor this. I cannot find a number that multiplies, two numbers that multiply to -5, but add up to 2. That doesn't exist. So the first one is not factorable. I'm just going to leave it as it is. But the second one, if you notice here, it's a difference of squares. We don't have to use decomposition if we recognize if it's a difference of squares. So I know it's going to be x minus 1 and x plus 1. However, we have a 3. That means there are triples of these, each of these brackets. There's 3 of them. So if I really want to write it more simplified, this becomes, I still have a bracket, x minus 1, x plus 1, but I know that there's going to be 3 of them, and there's going to be 3 of these. So if you notice here, how are we going to graph this? We're going to have to solve for the zeros. So in this case, we're going to set this one here to equal to 0. I'll just show all the micro steps. You're going to set each factor equal to 0. This becomes 1, this becomes -1. So I'm going to show all my work here. This here is not factorable, but you can get the zeros by using the quadratic formula. So that looks like the following. That gives you 2 squared minus 4 times 1 times -5. That gives you -2 plus, I believe that gives you 24 over 2. And then you have your 2 new zeros. So if you're to graph this, it would be the following. So we have this and this. We know we have 1 here, -1 here. And this turns out to be, this radical becomes, in decimal place, is -3.4-ish, and the other one is going to be 1.4-ish. Over here, 1.4. This is 1, this is 1.4-ish. And let's look at the end behaviors. Based on this function, if this is a quadratic and this is a, well, let's look at this one. We have a quadratic, a degree of 2. This is a degree of 3, a degree of 3. So this is a degree of 8. So the end behaviors of this, if you look at the factored form, so this is fully factored, there is no number in front that's positive, so therefore the behaviors, like the other ones, just a coincidence, is going to be, they're both going up. So we're going to go up and go up, so it's an octic, all right? And then based on this, from left to right, now because this function is a quadratic, which is actually broken up into 2, what this means is you just go straight through. It's a linear and a linear. And this one here at -1, what do we have here? We have a cubic-like function. I'll use red. So we're going to go down straight through, then we go up and try to make the best cubic-like inflection point at this 0 here. So basically I'm going to just try to make a parabola going down, facing down, and parabola facing up, and then I just keep on going. And what happens here, I do the same thing. There's going to be an inflection point, so I'm going to try to make a parabola that's facing up, and then a parabola-like feature facing down. So not a parabola, I'm just using the word parabola just to emphasize the shape of it. And this one here, you just go straight through.